Let's look at question number 11. In question number 11, the question reads as follows. In an exam, the average marks of 4 girls and 6 boys was 24. The marks scored by every girl was equal and every boy is same. That's what is assumed. So girls have scored same marks and boys have scored same marks among themselves. Girl marks is not equal to boy marks, but each girl has scored the same and each boy has scored the same. The marks scored by a girl is at most double that of a boy. G, if I assume G to be the marks of the girl and B to be the marks of the boy, G is less than or equal to 2B is the first condition. The marks scored by any girl is not less than that of a boy. G is greater than or equal to B. Not less than. So they can be equal, but G cannot be less than B. It can be equal to B. What are the possible number of integral values of the marks scored by 2 girls and 6 boys? What are the integral values? Given these two conditions and the average of this is 24. At the face of it, it looks a tricky question. Let's see how we can break it down. Let's apply the average formula first. 4 girls and 6 boys means a total of 10 students. And since each girl has scored the same and each boy has scored the same, I'm going to assume the girls' marks to be G and boys' marks to be B. So 4G plus 6B by 10 is equal to 24. If I take 2 common and I cancel this, I will get 2G plus 3B by 10 is equal to 12, which will give me 2G plus 3B is equal to 120. Alright, let's place this on the side. We have to find 2G plus 6B. This can be written as 2G plus 3B plus 3B, which can be written as 120 plus 3B. So, in essence, the question boils down to finding the number of integral solutions of this. Please pay attention that 120 is already an integer. So, 3B should be an integer, which brings me to the fact that B can be something like some number n by 3 in any form. It can be 2n by 3 or it can be an integer itself. Because if B is divided by 3, 3B should be an integer, which means B can be divided by 3. For example, 0.67, when I multiply this with 3, I get an integer. When I take 0.33, if I multiply this with 3, I get an integer. They are recurring decimals, right? If I take an integer, then 3B itself is an integer. Alright. The condition is G is less than or equal to 2B. So, 2G is less than or equal to 4B. Multiplying both sides with 2, 2G plus 3B is less than or equal to 4B plus 3B. This is equal to 7B. Now we know 2G plus 3B is equal to 120. So 120 is less than or equal to 7B, which will give me B is greater than or equal to 120 by 7, which is 17.14. So B is greater than or equal to 17.14. This is condition number 1. Let's look at condition number 2. G is greater than or equal to B. 2G is greater than or equal to 2B. 2G plus 3B is greater than or equal to 5B. So 120 is greater than or equal to 5B. So B is less than or equal to 24. Which brings me to the fact that B belongs to all values from 17.14 to 24. However, for this to be an integer, I'll want b to be of the form, let's say 17.3 bar, 17.67 bar, 18 and so on. If you observe, the next set of possible values b can take will be 19 and so on. So between 17.47 to 18, b can take 3 values. From 18 to 19, b can take 3 values. Every integer from 18 to 24, b can take 3 values. So 18 has 3, 19 has 3, 18, 19, 20, 21, 22, 23. That is 6 and 24. That is 7. So 7 into 3, which is 21. So the answer to this question is 21 number of values. Clear? Amazing. Let me repeat again. Why? 17.33, 17.67, 18. So 18 has 3 sets. 19.33, 19.67, 20. 18.33, 18.67, 19. So every integer corresponds to 3 values. Totally 18, 19, 20, 21, 22, 23, 24. 7 into 3, 21 values. There are 21 possible solutions or possible integral values of that.